G'day, lovely people. I hope you are all doing well. By way of introduction, my name is Andrew. You can tell because my shirt says Andrew. It would be weird if I was wearing someone else's shirt. It's Berlin, but I'm not, so we'll move past that. By way of introduction, or as an excuse for you to think that I am a person who knows sort of various things, here is a bunch of the things I've done. Started in 2013 apparently on PHP and cPanel and Elastic Beanstalk, and then kind of went through the various different roles, front end and back end, and DevOps and SysOps and infrastructure as code, and then a bunch of other languages and stuff, Prometheus and Docker and Kubernetes. And then most recently is kind of the most fun. These days I teach, or I try to teach. How successful it is depends on, I don't know, how much you like this presentation. No pressure. If you're interested in learning from me in a much more formal setting than this one, where I actually practiced what I'm going to teach you, then check it out on the internet. Cost you, I don't know, $20 or something. Maybe it's cheaper this week. Who knows? Anyway, my goal with this talk. So you saw a bunch of the technologies and stuff on the last slide. I've done a bunch of different things in my career and worked in a bunch of different roles, been called various different things, some of them polite. The kind of realization I had after all of this is that these notions, these kind of different roles that we occupy within the industry, whether it's a DevOps or a SysOps or an SRE or a developer, a front end or a back end or a Java developer. No Java developers. No, I'm messing with Java developers because I don't like Java very much. Anyway, it doesn't matter. The lines that break all of these different roles up are not really very convincing when you look kind of deeper at the technology and deeper at the choices that go into these things. So my goal is to really try and empower people, empower engineers, especially engineers that are probably 3 and 5 years into their career, to own as much of the software picture as they can. I think the more of the software picture that you own and understand, the more versatile your skill set, and the more you'll be able to solve interesting problems for more customers, earn more cash. Okay, so this is my goal. Okay, the last couple of years of my career has been focused around operations. So we're going to talk about operations. Specifically, we're going to talk about a class of problem that we all have. And the problem is users. If we don't have any, then we don't have any problems. No. Okay, so let's imagine that we have our application kind of deployed into production infrastructure somewhere in the cloud up there. I don't know. And then we have our users interacting with their application and there are no complaints. So we assume that the users are kind of doing their thing and everything seems fine. Okay, and then one day users start complaining to us a lot. Actually, they reach out on Twitter and through customer service and banging on the door and saying, your app is crap. It's all broken. Everything is down or something. I don't know. I have specific examples of this, which are really fun, but we'll come back to that later. So being the conscientious developer you are, you immediately try and, reproduce their issue. You ask them for an extensive bug report and they say, of course, and they fill out every step and you're like, oh, thank you very much. 10 out of 10. And then you go and reproduce that in your local machine to debug the issue and there's no bug. It's not there. So you're like, oh, fuck. Might be a production issue, so I'll deploy to staging, see if the bug exists there. No bug exists there. Fine. I'll redeploy to production, and then I deploy to production, and I reproduce painstakingly all of these tests, modifying accounts and placing transactions, and still no bug. Okay, this is a very frustrating state. So you're kind of complaining to your colleague, and your colleague says to you, look, man, why don't you go and actually look at production to see what it's doing? So you're like, oh, fine, you know what? It's not going to be anything there, but I'll go and look anyway. So you look at production, you see, logs and stuff. Seems to be talking a lot. There are some errors there. I don't know, but they've been there a really long time. Like something, eConnect fail seems error-y. But it's probably fine. It's been like that for ages. Maybe it's supposed to be like that. Fuck, I don't know. Okay, that's our problem. Our problem is that as engineers, as developers, sometimes it's really hard to reason through the state of production, to understand whether or not production is kind of doing the things that it should. And really hard, especially to understand whether or not the customer's perspective is as it should be. Okay, so we have this topic of observability. We're going to hit the buzzword bingo, 10 out of 10. We made it. Observability. Observability is our ability to reason through systems. It comes from control theory, and in control theory, this is where the definition comes from. It is a measure of how well the internal states of a system can be inferred from knowledge of its external outputs. So you have, a physical system, and the physical system does, physical things. It's a dial, and then that dial turns to a point, and then that point controls the amount of water out of a pipe or something. So you can understand from the external outputs the state of the system. For software, it is the same. You have software, and then you have an amount of data that comes from your software. Your users will request data to reflect some sort of transaction or state change, or I don't know, whatever it is that your app does. If you're very lucky or have otherwise seen this stuff before, then maybe you have some telemetry, some logs and traces and metrics and so on and so forth. Okay, so observability. The challenging part about having a system that is observable is that the systems that we work on, the actual physical stuff, the code and the orchestration and the databases and the hardware and the cloud, the actual things, well, they're not really real in the same way. Like take your application. You can take your application and compile your application. Your application will sit in some sort of like ELF file format, which then gets down to assembly, and then the assembly gets executed on some sort of series of cores based on whatever the kernel thinks is a good idea at the time and what you've told the kernel to do. And then, something, logic, gates, CPU, something, multiple levels of caches. Stuff gets dumped in memory, stuff gets dumped on disk. Then sometimes the stuff from memory gets dumped on disk, but it still pretends it's memory. Swap is funny. Doesn't matter. The point is that no matter how much you stare at a computer, if you physically had a rack in front of you and you kind of looked very carefully at it or listened to it, at most you can't really see computation happening. You can feel it. You can physically feel the heat coming off the machine as it's generating or putting more and more electricity through this silicon block, or you can hear the fans trying to push the heat away from the machine, but you can never actually see it. The way in which we interact with these systems is through tools, through coding tools, where we write in a particular language, which then gets compiled down, or we write unit tests to validate that, the compiled code that we use to test validates that the compiled code that we run actually works the way we expect. Or we'll look at it through deploying tools like kubectl, get blah, 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 or Docker PS or whatever. And then lastly, monitoring. We have an amount of data that we pull from the systems back out again, and hopefully can look up post facto to understand its internal state. All of these tools create a kind of a line of representation, a sort of a place that allows you to imagine what's going on in production. Interesting part about working with multiple people, each of those people imagine production a little bit differently. If you were to ask me how a computer works, I have no formal computer science background. I'm sure if you ask a computer scientist how they work, they'll probably give you much different answers, better answers, hopefully, gotta pretend that degree was good for something. Compared if you ask a DevOps or a sysadmin or blah, 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 blah. Everybody has a slightly different understanding as to how this stuff works, and that's fine. It means, though, that we all need the ability to reason through production in some way. More specifically, it means that observability happens in your head. It's not something that you can buy, although pretty much every vendor will attempt to sell it to you. Observability is your ability to reason through, to apply your cognitive capabilities to look at the data that you're seeing produced from your system and then kind of reason through, I've got a system that has an event loop, and then that event loop has a series of queues, and then those queues behave like blah, so on and so forth. So it requires you to think and to use the information in order to make your system observable. Okay, so blah, 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 lots of theory, tech conference, let's do some actual techie stuff. We have some code. I'm not going to live code it because we have 15 minutes and I'm going to screw it up. So let's look at an example. we're going to have a very cool application, which is an application that when you make an HTTP request to it, then it will return to you a rabbit, an ASCII rabbit for some reason, I don't know. Okay, so I find it easiest to think about the challenges of observability by thinking about the problems that we actually solve with these challenges. Let's take a simple problem that, let's imagine that we compile our application and then we try and run our application, / whatever, and the application does nothing. Certainly doesn't start the server like we expect. In fact, if we query the exit code that the application returned to its owning process, to bash in this case, then it will say, I am exit1, which means I exited badly. That's it. It tells us nothing else. At least it tells us something. So how are the owners of this application? We can look at the code. We look at the code. We see that it does a series of pre-run checks. In those checks, that it will, check a bunch of flag information, and it will try and read some configuration. And if it fails to read the configuration, then it will exit with this exit code of 1. This is a possible failure condition, not necessarily the condition, but what we can do is we can add some locks. We add some information to each of the conditions that indicate this program is doing something that, it shouldn't. Something bad has happened. And then when we run the application again, then we see some more helpful information to understand a specific state. We try and run the application and it says, I failed to read the configuration. So you're like, okay, didn't know you needed a configuration file of the application, but I'll create one for you. It's just going to be over there. It's going to be blank, but maybe it makes you feel good. So you create the configuration file, you run the application again, and you get another error that you weren't expecting. This time it says cannot run on port 80. This is what I mean by combining information that you sort of have in your head, your understanding of production system, with the outputs of your process. Here it says permission denied. You might look at this and you might say sudo. Okay, there's another answer. Basically, from your experience that any port below 8000 is a privileged port because Unix. So you then just try and run it with another port above 8000. You run it and it works. You're good to go. You can curl it and then you will get back a rabbit. Mission success. Okay, problem number 1. Let's look at problem number 2. This one comes from our users. We have the user Elmer Fudd, who is making requests to our application looking for the rascally rabbits, but those requests are failing. So we look at our application code. We're like, yes, very good. Seems like a bunch of code. And if you look carefully between 42 and 55 on the screen, you will see why Elmer Fudd's requests don't work, but pretend you don't, because it's not very good for my exercise. We need to modify this function to produce some sort of side effect that we can then go back later and check. The tool that is most useful for this is called distributed tracing. Distributed tracing creates these transactional records which exist across multiple different microservices within your infrastructure. It creates almost a call graph-like structure, a structure that allows you to detail how each application handled a particular request across service A, B, C, D, E, F, so on and so forth. It does this by working with something called a span. A span is a diagnostic record for something that has a defined start and an end. It usually reflects some sort of operation or transaction or something that does a logical unit of work. And it has a name and it has a series of attributes. These are things that either go into the operation or come out of the operation, or metadata about the operation, whether or not it was successful. For local, use Jaeger. For production, use Lightstep. I'll tell you why later. So you have to bootstrap this. It's pretty complicated. I'm going to skip most of this for the moment because we're running out of time. Blah, 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 blah. Okay, so we instrument our application, and we instrument it such that we track the status code, and we track the user agent, some information from the user's perspective, and then we track the different blocks of logic, or the different logical paths that we can go down, including the error path. We then try and make a request, and we see, yep, good to go, works on my machine, problem solved, no worries, from our Chromium user agent. And then we say, Elmer, give it a crack. And he goes, yes. What he didn't tell you is he's using a specific user agent. So you look at this and then you go, okay, that's a bit strange, but now I fully understand why your requests are failing. Your system is now much more observable. You can reason through more of its potential internal states. That's it. That was a speed run of, I don't know, what was like 2 or 3 hours of content or something. Any questions, then reach out to me afterwards. Beyond that, check out the full material on the internet. Cost you $20 or something. Thank you very much. See you later, people.